Hello and welcome to another video. So this is actually really exciting. This is one of my paper 1 predicted papers. So for those of you who are not in the Discord yet, join the Discord, and under the graded papers I've actually uploaded 3 paper 1s and 3 paper 1s for AQA and Edexcel. Okay, so this is specifically paper 1A. The reason why I've got 3 versions is because what I've done is I have a spreadsheet where I've gone through every single past paper, put it all into a spreadsheet, and then I've worked out the most likely thing to come up for each question. And I made 3 versions to make sure I kind of cover as many of my bases as humanly possible. Now, just so you know, this isn't like a grade 9 paper. This is what I actually think the paper will look like, which means it's not going to be super difficult like it is in the grade 9 papers. So again, if you want access to those for AQA or Edexcel, at the moment it's only higher tier paper 1s, but I do have foundation tier paper 1s, and paper 2s and 3s are also coming as well. Join the Discord, the link is in the description, and that way you can get access to them. You can download them completely for free, and you can try them yourself. And the Edexcel one should come out on this Sunday, hopefully. But without further ado, let's just get to it. So, we have first some classic multiple choice. Again, in the last few papers they may not have had these, but keep in mind, this is pre-COVID, most of this information is from, which is what they want to get back to. So work out the value of the cube root of 64 minus 37 squared. So all you have to do here is work it out piece by piece. So cube root, and we have 64 minus 37. So what would that be? That should be 27 squared. That should be a 2, my bad. It looks a bit like a thing. Now, of course, well, you might look at this and say, okay, I don't know what 27 squared is, and then I have to cube root that. No, you can cube root first. So the cube root of 27 is 3, and then you're squaring it, which gives me the answer of 9. Okay? 4 squared times 4 cubed, circle your answer. Well, this is going to be 4 to the power of 5, right? Because you add the indices. By the way, as a quick aside, I do have mark schemes for all of these papers, as well as video walkthroughs, but the video walkthroughs I did a while ago, so it's not as good as my current stuff. So I'll also put the mark schemes in the Discord as well, so you can mark your work, but I'm going to leave it a day or so, just so I can A, check the mark schemes, and B, so that way you have a chance to do them completely yourself, because that is the best way to learn. Okay, simplifying this, all you need to do is do 4x, and then we're going to have 2 copies of this bracket. So we have 4x plus 4x squared plus 2x plus 2x plus 1, because again we have first outside, so 2x times 2x is 4x squared. Then we have 2x times 1, which is 2x. 1 times 2x, which is 2x. 1 times 1, which is 1. Then we can add this all together. We have 4x squared. We have 4x plus 2x plus 2x. So in total that's 8x, right? 4 plus 2 plus 2. And then plus 1. So that is our first option over here. Then it says solve 4 cubed to the power of 1/5. So what they mean by this is you need to write it in terms of this kind of notation. So 4 cubed to the power of a 5th is the same as taking the 5th root of 4 cubed, which is that value there. Okay? Nice and easy. The other way you could have done it is potentially this one, but the main difference here is that the cubed comes first. That's why I didn't pick this one, okay? The cubed comes first, then we're taken to the 5th, if it's in brackets like this. Then we have an inequality that we're going to solve. So 3x plus 2, so that's going to become 3x plus 6 is greater than 4x minus 10. So how do you solve inequalities? What you want to do is you want to treat this as if it's an equal sign, really. You want to get all of the x's on one side and then everything else on the other side. So if I look at 4x and 3x, 4x is bigger, so I'm going to move the 3x over to the 4x, and you do that by subtracting 3x from both sides. So now we have 6 is greater than 4x minus 3x is just x minus 10. So what's stopping the x from being by itself? It's that minus 10. Opposite of minus 10 is adding 10. So we have 16 is greater than x. The other way you can write that is x is less than 16. Either way round would give you the full 2 marks. Then it says work out the percentage decrease from 360 to 90. So percentage decrease is just the same as percentage change, except it's going to be negative. You take the new number, 90, you subtract the old number, 360, and divide it by the old number, and you times it by 100. So 90 minus 360 is minus 270 over 360. So, and then again, we're still timing that by 100. And what would that be? Well, I can divide them both by 9, right? So the way I'm going to do this in my head is if you ignore the zeros for now, 27 and 36, I can divide them both by 9, can't I? Right? So in fact, that's the first thing I'm going to do is I'm going to cancel out the zeros, and then I'm going to divide top and bottom by 9 to simplify a bit. That gives me minus 3 over 4 times 100. 3/4 as a percentage is just 75%. So it's a 75% decrease, or negative 75%. Okay. If you want another way to change this fraction into a percentage, so I personally times by 100. The other way you could do it is just make the bottom equal to 100. So if that's your preferred method, you would have 3 over 4. How do I make that into 100? I times top and bottom by 25, which gives me 75 over 100, which of course is 75%. So it's a 75% decrease. So when I say it's the same as percentage change, if I just do percentage change, I get a negative for percentage decrease or loss, and I get a positive for percentage profit or gain. So I don't really need to use 3 different equations. I can use one equation and just use the fact that the negative means a loss. Here's a recipe for chocolate chip cookies. 100 grams of brown sugar, 150 grams of butter, flour and chocolate. Robbie has 450 grams of brown sugar, a kilogram of flour, 500 grams of butter and 300 grams of chocolate. Was the maximum number of people that Robbie can make cookies for. So basically, how many cookies can Robbie make? So what we want to do is work out how many cookies we could make if we had just this, just this, just this, and just this. And what we can do there is see whatever one is the smallest number is going to be our kind of bonus. So if we look at brown sugar, first of all, right? 450 over 100 will tell me how many batches of cookies I can make if brown sugar was like my limiting ingredient, right? So I have 4.5 times as much brown sugar as I need. Now, this makes chocolate chip cookies for 6 people, 6 cookies, right? So all I'm going to do is do 6 times 4.5, and what that will give me is it will give me, first of all, I'm going to make this 9 over 2. What that will give me is the multiplier, right? That'll give me how many cookies I can make. So we're going to do 6 times 9 over 2. 6 times 9 is 54, so that's 54 over 2. So in other words, this will give me enough for 27 cookies or people. Okay? Cool. Again, there are other ways to do this, by the way, so if you have another way, it's completely fine. Let's do the flour next, because that's the next one in my list. We have a kilogram of flour, and we only need 160 grams of flour. So what we do is we do 1,000 divided by 160. Now you might notice this won't go in like a total amount, right? Because we're basically just doing 100 divided by 16. How many 16s go into 100? We have 16, 32, 48. Well, it goes up to 64, right? So 16, 32, 64. Then we have 80. Then we have 96. So it goes in 6 full times, right? Now, there's a reason why I'm not including the decimal. Because I actually only care about the smallest number, right? Now let's think about why I'm saying that. Why am I saying that? The reason for that is if I have enough flour for 6 batches of cookies, right, but I only have enough brown sugar for 4 batches of cookies, I can only make 4 batches of cookies, right? I can't make a brown sugarless chocolate chip cookie, apparently. So with flour, I actually don't need to work that out because it's 6, okay? So let's go on to the next one. Let's go to butter. Okay, 500 grams of butter. We have 150. Cool. So now what is 500? Let's do it on this other side. Divided by 150. Well, that goes in 3 times fully, right? 150, 300, 450. Then I'm left with 50 over 150. So that's 3 1/3 times. So, okay, that's my new minimum, right? So 3 1/3 times 6. Well, 6 times 3 is 18. And 1/3 of 6 is, whoops, is 2. So I can make 20 cookies. So now that's my new minimum, right? That's my new maximum number of cookies. Okay? Because that's my new smallest value. Cool. Now with chocolate, alright, let's have a look at chocolate, shall we? We have 300 grams of chocolate. And 300 over 80, well again, 80, 160, 240, so that would be 240, and that would actually be 2/3. Sorry, not 240. That should be 3 2/3. Okay. And now, again, this is my minimum still. Now, what I mean by the minimum, this is the kind of smallest number of batches I can make, right? Now, again, with ingredients, that means it's the biggest number of batches I can make. Because, again, I only have enough butter for 3 1/3 batches of cookies. I can't make 3 2/3, I can't make 6, and I can't make 4 batches of cookies. Because I don't have enough butter, right? So, the maximum number of people that Robbie can make cookies for is going to be 20 people. Because that is my limiting ingredient. So I hope that makes sense. Okay, you don't need to work out all of them, just work out the smallest one. The nth term of a sequence is 6n minus 3. What's the first 3 terms? Well, first 3 terms are when n equals 1, which gives me 6 times 1 minus 3, which is 3, so that's my first one. N equals 2, that's 6 times 2 minus 3. 6 times 2 is 12, minus 3 is 9. And then when n equals 3, we have 6 times 3 minus 3, which gives me 6 times 2 is 18, minus 3 is 15. And now the way that the grading works the marking for this question, the way it works is you basically lose a mark for every one of these that you get wrong. Okay, so be super duper careful. Which term is equal to 45? So the way I do this question is a bit different to what some people do. The way I do it, and this is kind of the A-level way to do it as well, if you're interested, is I make this equation equal to 45. And then I'm solving for n. Add 3 to both sides. We get 6n is equal to 48. So that means n is equal to 48 divided by 6, which equals 8. So it's the 8th term. Bill says 645 is in this sequence. Is he correct, yes or no? Well, again, I'm going to do the same thing I just did. I'm going to make this equation equal to 645. So 6n minus 3 equals 645. Yeah? Add 3 to both sides. 6n equals 648. Now, I'm going to show you a trick. I already know that this is 108. Now, how did I do that so quickly? Well, 6 goes into 600 100 times. 6 goes into 48 8 times. So that's how you do that. The other way you could do it, if you really wanted to, is you can use the bus stop method, which will give you the exact same result. 6 into 6 gives me 1. 6 into 4 gives me 0, remainder 4. 6 into 48 gives me 8. So because I get a whole number, the answer is it is in the sequence. In the exam, they can give you, obviously, where n is going to be, let's say, a fraction or a decimal. Then the answer would be no. Because think about it, what is n? It tells you what place you are in the sequence. First, second, third, fourth. Can you have 1.5th in the sequence? 2.37th in the sequence? No. Imagine you're running a race, right? And you have 10 people in the race. Can there be a 1.5th person? No, right? So it has to be a whole number. So, whole number, so it is. Okay, making good progress. Okay, this diagram shows the value of a car. Sarah purchases the car for £22,300 and it depreciates by 20% each year. What is the value of the car after 2 years? So I do truly believe that they're going to give you a depreciation question in non-calculator. Because again, this is something I've said a couple times now in a few other videos, any topic can come up in any paper, calculator or non-calculator. A lot of students have this conception that there are calculator topics and non-calculator topics. There aren't. All of it can turn up in any paper. Now, this hasn't turned up in a very long time. However, my school and a few other schools actually did this in the mock, where they gave you a depreciation question in the mock exam, in a non-calculator mock exam. And that, again, hints to me that they're probably going to do it in the real exam as well. Possibly, right? But either way, we have to just think about the depreciation. So let's get to it. So depreciates by 20% each year. So in year one, so let's say the first year, the value goes down by 20%. So what we're going to do is find 20% of the value of the car. So 10%, all you do is divide it by 10. So that'd be 20 to 30, so £2,230, which means 20% is equal to £4,460. So after the first year, the value of the car is going to be 2,300 minus £4,460. So whatever this value is, 0 minus 0 is 0. Borrow, that would be 4. Borrow, 12 minus 4 is 8. Borrow, 11 minus 4 is 7. 1. £17,840. Okay. Second year, we repeat the exact same process. 10%. Now, 10% is going to be a bit more interesting. It's £1,784, which means 20% is double that, which would be 3,568. Yeah? I hope. Yeah, I'm pretty sure it is. Okay. So now we do the exact same thing again. So we're going to do 17,840. One recommendation I have, by the way, is your guys' handwriting sucks, right? Just like mine does. But the way you lay your working out is very messy. And when you have like adding and subtracting, we tend to rush it because we're in an exam. We don't want to focus on the easy stuff. But please, for the love of God, space out your numbers, okay? So you don't end up accidentally adding slantedly, right? Like doing 3 minus 6 accidentally. And I've seen loads of people do that. So again, cross that out, make that a 3, make that a 1. Again, my handwriting sucks too, so it's fine. But even people with neat handwriting, it's going to cause issues with yourself, okay? 7 minus 5 is 2. 1. So the final price of the car is £14,272. 3 marks. Again, I don't think that was too tricky, right? But I can easily see certain people panicking because it's, oh my god, it's depreciation, it's normally calculator. Yeah, you're right, it's normally calculator. It's just not always. Okay. Here we go. X to y is 5 to 2. X plus y is 49. Work out the value of x times y. So I actually have a ratio video coming out, I think like 2 days after this one, so that should be interesting. But this is, again, a fairly tricky situation. So the way we use this top piece of information is x to y is the same as 5 to 2. So what we know is x over y is equal to 5 over 2. And all we're going to do is we're going to work out the value of x and y and then work out the value of x times y. Nice and easy. So x is equal to 5 over 2. I don't know why I didn't put the equal sign. 5 over 2y. So if I sub that into this equation now, I have 5 over 2y plus y equals 49. So 5 over 2 plus 1 would be 7 over 2, right? So 5 over 2 plus 1 over 1 times top and bottom by 2, we get 5 over 2 plus 2 over 2. So we get 7 over 2. That's where I got that from. 7 over 2y equals 49. Now it's not a mistake, right? It's a lot of people times this by 2 and you get 98, right? And then they divide by 7. Here's a little bit of a tip. You can actually divide and times in any order. So if you divide both sides by 7 first, the numbers get a bit easier, right? We get a half y equals 7. which means y is equal to 14, which is a bit easier than doing 2 times 49, which is 98, and then dividing that by 7. So the order you can kind of manipulate to make the numbers easier for yourself. Again, you wouldn't be wrong if you didn't do that, but whatever. So then what's x? Well, x is 5 over 2 times y, right? So we can do the division first. 14 divided by 2, so that's 5 times 7, which is 35. And 35 plus 14 is indeed 49, so I know I'm correct. So now x times y is just 35 times 14. So 35 times 10 is 350, plus 4 times 35. Well, that would be plus 140. And this is how I'm doing it in my head, by the way. So I thought it would be fun for us to kind of go through the mental math side of things. But to be honest, I would just recommend doing it manually, right? But you can use this to check your answer, which is really, really important. Okay, moving swiftly on. Work out the size of angle X. Okay, perfect. So, some trigonometry. Once again, something that you tend to see in the calculator papers, but again, in your spec, you need to know certain values, right? So, how am I going to do this? Well, we want an angle and we have two sides. So trigonometry is what's screaming out at me. So I'm going to label up my sides. The opposite the right angle is always the hypotenuse. Opposite the angle we want or have is always the opposite. And the leftover one is A. So I'm going to write out SOHCAHTOA. Now, which sides do I want or am I interested in? Well, it's A and H, right? So I have cos X equals A over H, which means cos X is equal to 6 over 12, which in other words is a half. So X is equal to the inverse cos of 1/2. Now you need to think about what angle gives you a half when you're talking about cosine. Right? So it's kind of the backwards version. The answer is 60 degrees. Okay? But it's kind of a backwards version of it, right? Normally they say you need to know cos 60 equals a half, cos 30 equals this, etc. Or sine 30 equals this, whatever. But there's no reason why they can't ask you the reverse. Okay? And again, because they want to get back to pre-COVID days, they want to kind of test new things, they want to go back to the kind of harder papers. And if you look at the 2017 papers, they were pretty damn tricky. I do think that they might try and slip something like this in. So what I'm trying to say is, with those values of sine, cos and tan you need to know, try and know them backwards as well. Okay? So, table shows information about the wait times for a sample of 50 people for a fast food delivery service. So this is in minutes, okay, this is in the frequency. The statements are about the mean, median and mode of the actual time. So we have quite a bit of stuff here. For every one you get wrong, you drop a mark, okay? So, if you look at this data, we have a big peak here. Okay, cool. The mean could be less than 20 minutes. Okay. Is that true or false? Well, here's how I look at it. The mean's going to be the middle value, right? Now, that means it's going to be very close to this. Now, how many values do I have smaller than 20 minutes? Well, in total, it's going to be 23 plus 9, which is 32. How many values do I have above 20 minutes? We have 18 values, right? Now, keep in mind, the reason why I've included this 23 is because 23 are between 10 and 20, which if you notice is going to include less than 20, mostly, right? So it's probably going to be less than 20. Now, could it be more than 30? Well, if I look at more than 30, that's only 7 people. There's no way in hell that it's more than 30. Could it be less than 30? Well, yeah, if it could be less than 20, it could be less than 30, right? What about the median? It's equal to the mean. Okay. Well, the median, again, is less than the... is less than 20, right? So it's going to be all of these values in order. The values are already in order, so it's going to be the middle value. And we have 50 people, so 25 people would be in this class here. So it would be between 10 and 20. Right? Now, is it equal to the mean? Well, that is a statement. It doesn't say it could be equal. It could be equal, but it's not guaranteed to be equal. The median would be an inaccurate measure. I mean, I can't really imagine why it would be inaccurate, per se. but you would get a range, you wouldn't get an exact value, right? So this would be false. So it's not inaccurate by any means necessary, but you wouldn't get a precise value. And lastly, the median's greater than the mean. Again, you can't actually say whether or not it is. Okay. Tina and Rosie shared £565 in the ratio of 3 to 2. Then Tina lends Rosie some of her money, so they now have the same amount. How much did Tina lend to Rosie? So all we need to do is, well, there's two ways to do this. One way is to work out how much money Tina has, how much money Rosie has, meet in the middle so they have the same amount of money, and work out the difference. There is a cleverer way, though. There is a bit of a cleverer way. If we just work out the difference between the people and half it, we'll be done. So, for Tina, she gets, and again, changing a ratio into a fraction, you look at the number associated with Tina, which is 3, divide by the total number, which is 5, you times it by 565. So we need to do 565 divided by 5, so 5 into 565. 5 into 5 is 1, 5 into 6 is 1, remainder 1, and 3. So it's 3 times 113, which is £339. And Rosie is going to have 2 over 5 times 565, which is 2 times 113, which is £226. Now, for them to have the same amount of money, they need to meet in the middle, right? So all we're going to do is take the difference in this money and half it, and that's how much they've given to each other. Because the difference is 113, right? So subtract it. There's a difference of £113. Now, for them to have the same amount of money, they need to, well, Tina needs to give half of that to Rosie, so Rosie gets that half back, so it balances out. So all we need to do is half 113, which would be 56.5. So 113 divided by 2. And the reason why I've got that is 55 is 100, half of 110, so £56.50. Again, you can use good old-fashioned bus stop method. 2 into 1 is 0, 2 into 11 is 5, remainder 1, 2 into 13 is 6, and then there's a remainder, so we need to put a decimal point, remainder 1, 2 into that will give me, sorry, I shouldn't have put the 0 up here, that was a small oversight, 5. Easy peasy lemon squeezy. Okay, and for question 14. Now we're on to cumulative frequency for question 14. So we have some information about the scores of 100 students on a test. Complete the cumulative frequency table. So first things first, we're going to have the score here. And here we're going to have the cumulative frequency, right? And here's the important things. First, you need to know how to actually work out cumulative frequency. And the second thing is you actually need to kind of know how to write this. Now, there's actually two different ways. You could write this exact kind of table here, and that's fine. However, there's another way to write it that I want to show you, which is technically a bit more accurate. So S is less than or equal to 50, then S is less than or equal to 60, like this. Now, again, both methods, or both ways of writing it, so this way on the left and this way on the right, are both accepted, so you don't need to worry about which one you do. But just so you know that if they do write it in the way I'm writing it now on the right hand side, that doesn't mean that they're wrong or anything like that, okay? It's just a different way of writing it. Now, the cumulative frequency, all you do is you're adding the numbers as you go along. So we have 6 here, and the next one is 6 plus 14, so we have 20. And then we have another 47, so that's 67. Another 22, that's 89. Another 9, that's 98. Another 2 gives me 100. And now the part B is probably going to be, draw the cumulative frequency graph. Now, what do you actually plot? What you do is you plot the midpoint against the cumulative frequency. So the midpoints are 45, 55, 65, 75, 85, and 95. So 45 and 6 would be your first one. So midway would be about here, and 6 would be, so what's this going up in? There's 5 here, so it's going up in 4s. Okay, cool. So 2.5, and we have, so 45, right, 45, and that'd be 4, 8, so it should be right in the middle of both of those two things. And for the next points, oops, dropped something. For the next point, it'll be 55 and 20. So 55 would be midway through here, and 20 is right there. 65 and 67, so quite a bit of a jump. 60, and what does it go up in? Well, it is 20 and there's 5 spaces, so it goes in 4s. And 67 would be boom, boom, right before here, so we're going to make it a very tiny dot right before that value. 75 and 89. 75, 84, 88, 89 would be just above that line there. Again, it doesn't need to be super accurate. Then 85 and 98 would be halfway between those two boxes. And lastly, but certainly not least, 95 and 100. And now, what do you do? Well, what you need to do is actually connect the dots together with a straight line. Now, of course, as you know, graphics tablet, not the easiest thing to draw straight lines with. But you want it to be like a connect the dots, right? So there should be very sharp changes in direction, okay? Like that. Cool. So let's work out the value of 3/12 divided by 3 to the power of 6 divided by 3 to the 4. So first of all, if we have a 6 and a 4 outside the 6, then what we have is 3, and we multiply those two numbers. So what that means is we're going to do 6 times 4, which is 24. When we're dividing, it means we subtract, which means it's 3 to the power of minus 12. And it says give your answer as a fraction in its simplest form, so that would be 1 over 3 to the power of 12. Simplify here, giving your answer in the form a plus b root 15. So this is simplifying surds, which I know a few of you have asked for help on. So if you have a look, it's saying that we should have a number, and if you look, root 81 is actually equal to just the number, and the other thing should be split into a number and a surd. So what we can do with surds is we can split them into two numbers that multiply together to give 60 in this case. So one of them has to be 15 because it tells me one of them is 15. So what is 60 divided by 15? Well, that's square root 4 and 15. Which we can separate into two separate surds like so, which is just 2 root 15. So my answer is just 9 plus 2 root 15. Nice and easy. Expand and simplify. We have 3x plus 5 and then 3x minus 4y. And this is expanding triple brackets. Pretty tedious, but it's not too bad. X plus 5. Then in this case we have 9x squared minus 12xy minus 12xy, and then plus 16y squared. So let's gather the like terms now. X plus 5, 9x squared minus 24xy plus 16y squared. Now expand the third set of brackets, so that would be 9x to the power of 3 minus 24x squared y plus 16y squared x plus 45x squared minus, so 24 times 5, that's actually a good question, it'd be 120. And how I did that is when I times by 5, I times by 10 and then half it. So minus 24 times 10 is minus 240, half that is minus 120 xy, and then again 16, that'd be 80 y squared. And if I look, you can't actually simplify that any further. Right? Which is why this is only 2 marks, because there's only 2 steps. The simplify bit we don't actually have to do. Because if you look, x cubed, nothing else, x squared y, nothing else, y squared x, nothing else, x squared, nothing else, xy, nothing else, y squared, nothing else. All easy, good job. Point P is a point on the circle, center O, and the tangent at P intersects the point here, A and B, and it says the gradient is minus 2/3 of the tangent. Work out the y coordinate of P, and it gives us the point here 8, 12. Okay, so with this question, we have the point P 8, 12, and I have noticed a small error on the thing, so this should be a 12 here. And the question should be, work out the y coordinate of B, not P. So I apologize if that confused you. I'll try and get that updated before anyone else downloads it anyway. But yeah, that should be what it says. You wouldn't believe that I actually, like, you know, checked this multiple times. And we need to work out the y-coordinate of B. Now here's the thing. We can write our equation for that line as mx plus c, and it tells me that the equation is 2/3 already x plus c. So effectively all we're doing is trying to work out the value of c. Now we have a coordinate 8 and 12. So when x equals 8, y equals 12, so sub that in, we get 12 is equal to minus 2/3 8 plus c. So that gives me 12 is equal to minus 16 over 3 plus c, which means c is equal to 12 plus 16 over 3. So I'd have to make that 12 equal to 36 over 3. And then when I add that, I get 52 over 3, okay? And that's going to be our y coordinate, okay? And we can't simplify that any further. So the y coordinate of B is just 52 over 3. Cool. Here are the first four terms of a quadratic sequence. So there are so many different ways to do quadratic sequences, but the way I do it is very mathematical in the sense that there is absolutely no guesswork whatsoever. Here's what we do. We look at the common difference. 16 to 22, that's a difference of 6. 22 to 30 is 8. Next one's 10. Now, because the difference is all different, we're going to take the difference of the difference, which is 2 and 2. Now, that number, whatever it happens to be, is the first part of our equation. So in general, a quadratic sequence looks like this, right? It's going to have n squared and n, c, and then it's going to have some numbers. Now, a is just equal to a half of this. So already my equation is now just n squared, because half of 2 is 1, n squared plus bn plus c. Now what do I know? Well, I know that when n equals 1, right, it should equal 16. So we have 1 squared, which is 1, so we have 1 plus b plus c is equal to 16. So in other words, we have b plus c equals 15, because I'm moving the 1 to the other side. And when n equals 2, we know that it equals 22. So 2 squared is 4, plus 2b plus c is equal to 22. Move the 4 over to the other side, we get 2b plus c is equal to 18. Now what we can do is actually subtract these two equations. So what I'm going to do is I'm going to move these on top of one another. And we're going to subtract the equations. And we're left with b equals 3. Now if I sub that into this equation here, b equals 3, then that means c must equal 12, because we get 3 plus c equals 15. So my final equation is going to be n squared plus 3n plus 12, which should give me all of those values in that expression. For 20a, diagram shows rectangles a and b. Rectangle a can be mapped onto b in a single transformation. Marcus says 1 is a translation in the x-axis because the rectangles have the same y-coordinate. Is he correct? Yeah. Now what is the reason? Well, all you have to do is work out what the translation would be. It'd be 1, 2, 3, 4, 5, 6, 7. So translation 7 to the right. Maps A onto B. And that would be your justification for your answer. Now here's a bit more interesting. CDE is mapped, so this triangle here is mapped onto this triangle here by combining 3 transformations. The first is a rotation 180 degrees around E. So here's how I do that. What I would do now is I would draw out what that looks like. So it should be 3 high, so 1, 2, 3. That's what it looks like after the initial transformation. Now what we have to do is say what the second and third transformation is. Now if you're looking at this and you think I could do that in less than 3 transformations, that's fine. But in this question it specifies that we need to do 2 more transformations, okay? And this again is a fairly tricky question. So what I would do is, I'd say one is a translation and the other is a enlargement. Okay, so the first one, we're going to try and move this over to here. Okay, so how many to the left would that be? That'd be 1, 2, 3, 4, 5, 6, 7, 8, right? So we're going to say it's a translation by vector -7, 7 to the left, and 0 up and down. And what that will do is we'll move it on there. Actually, I've just thought of something even better. We'll move it 1 down as well, vertically. Because that way, E is now right on top of P. Okay? So now my actual kind of thing looks like this. So we have point here, 1, 2, 3, 1. So this is what my triangle now looks like. So as you can see, it's very similar to what that is. So what's the difference? Well, now we have an enlargement by scale factor. Well, what's the scale factor? Well, the edges of this triangle here is 1, 2, 3, 4, and this is 2. So the scale factor is 2. And what's the center? Well, the center would be point P, okay? Because it's not moving. So that is -4, -3. And those would be your two separate ones, okay? So even if you can do it in one, just keep that in mind. There may be other solutions as well, but you just need to check it as and when needed. Okay, so with this one we have a cylindrical tank. It has a top and a bottom. 6 of the tanks are going to be painted. Each tank has a diameter of 60 centimeters and a height of 2 meters. Each pot of paint can cover 5 square meters. How many pots of paint are needed to paint the 4 tanks? And you can take pi as 3. So the question is, if we're painting something, are we looking at the volume or the area? And we're looking at the area. Now with the area of a cylinder, the surface area, you have 2 circles, right? Because, which by the way is why it says it has a top and a bottom, because it's sealed, right? So we have 2 of these circles here. And when we do kind of the area of them, we have pi r squared, right? Now here we have the diameter, so we want the radius. So the radius is going to be half that, which is 30 centimeters. And we're going to do all of our calculations in meters because that's what it gives us, okay? So in meters, that's 0.3 meters, okay? And if we look at the... So what else do we have? Well, if we substitute that in, we get pi r squared. I don't know why I did that. We get pi times... If you want, we can actually leave it as 30 squared and then divide it to get our actual answer. So that will give us, so 3 times 3 is 9. Give you 900 pi, right? Now, in meters squared, that's centimeters squared. To change to meters squared, we need to divide by 10,000, okay? Which means if we divide by 1,000, we get 0.9. So we essentially get 0.0009 pi meters squared. And then we also have a rectangle, which makes up the kind of wrapped around cylinder, the height of which is 2 meters, okay, and the width of which is going to be the circumference of a of the circle, which is 2 pi r, or 2 times d. So, or sorry, pi times d. So if that's the diameter, then we're going to have pi d, which is equal to 60 pi centimeters. But remember, we want it in meters, so we have 0.6 pi meters. And the area of that is just going to be 1.2 pi. Now, of course, since we know that pi is 3, we can now times these both by 3. So 1.2 times 3 is 3.6 square meters. And if we have this, well, we probably should have done this beforehand actually, but that would be 0.0027 square meters. Now that means the area of one tank is just equal to 3.6 plus 0.0027, which is equal to 3.6027 square meters. Now, if you have a look, each pot of paint covers 5 square meters. How much is needed to paint 4 tanks, okay? So we need to times that by 4. Now, I'm actually going to show you a bit of a trick. Because each pot of paint can just cover 5 square meters, we don't actually need the decimal places. So I can actually ignore these 3 decimal places, okay? So I'm going to do 3.6 times 4, double it 7.2, double it again gives me 14.4 square meters. And again, I'm going to truncate this. So I'm going to get rid of it. Because again, if each one's covering 5 square meters, all I know is it's basically 14.4. Now if each one covers 5 square meters, we need 3 pots of paint to cover that, okay? So again, this question here, if you remember, if you read through a spec one more time, it does say that you're expected to be able to estimate and approximate when necessary. So in this case, I'm going to say the 0.27 doesn't matter. It doesn't make a difference, right? Because each pot of paint does 5 square meters, so I only really care about the first 2 significant figures, maybe the third one, but in this case it's 0 anyway. So that's what I've done there. 3.6 times by 4, again, if you double it, you get 7.2, double it again, you get 14.4. You get 14.4054 if I left that there. Does that change the answer? No, it doesn't matter. Simplify this. Okay, so again, we're going to use the fact that this is going to be 5, square root 25, and that's going to be 9. Now, square root 225, that's interesting. We can try and change it into 2 separate things. Okay, so let's think, what could we separate it into? Well, what can I divide it by? Well, I can divide it by 5, so let's start with 5. Square root 5, and that is square root 45. How did I divide this by 5 so quick? Divide by 10 is 22.5, double it gives you 45. Okay, now what could I change that into? Well, we get square root 5, and square root 45 is square root 9, square root 5. Square root 9 is just equal to 3, and then we have square root 5 times square root 5, which is 5. So all in all, we get 3 times 5, which is 15. So when I simplify this, I get 15 on the top, over 5 times 9, which is 45. Divide the top and bottom by 15 to get 1/3. That is the simplest possible way of doing it. Fancy. F of x is equal to x squared. Draw the graphs of y equals f of x and f of x minus 2. So for f of x, then we're going to have something pretty simple. We're going to have, if we start with, let's say, 3 here, and we're going to have 3 back up to 9 here. So it's something that's very steep. It goes something like and it touches the x-axis at the origin here, okay? And with x minus 2, what does that mean? Well, since it's inside the bracket, it affects x, and it does the opposite of what it says. It adds 2. So in total, we're adding 2 to x. So I'm moving this whole thing across by 2. So this is my y equals f of x. And I'm going to do this in a different color, just to make it super clear. We're going to have the exact same kind of points, if that makes sense, but they're all going to be moved over 2 to the right. And we're going to draw the exact same thing. The actual shape does not change. Something like that. And that will give you your marks. Okay, shampoo bottles are on sale at 3 shops. The normal price of a shampoo bottle is the same at each shop. What is the cheapest way to buy exactly 8 bottles? You can buy from more than one shop. You must show your working. So, if we have a look at this, you can either get 30% off of just 1 bottle. You could get 2 bottles with 2 half price. You can get 1 bottle and the next one at half price. So both of these shops are actually very similar. In fact, they'd be the same in this case. Now, if you have 30% off a bottle, that means you're going to be paying 0.7%, right? So if I were to buy all 8 bottles like that, what would I get? Well, I'd get 8 times 7, right? And then I'll just need to divide it by 10. So 8 times 7 would give me, so 714, it would give me 56. So it'd give me 5.6 bottles here. However, if I do 2 bottles and 2 more half price, right? Then every 2 bottles I get 2 for free. So I get 2 and then I get 2 for free. Then I get 2 and then 2 for free. So these 2 are free. So in total I've only paid for 4 bottles. So for here, we've paid for 5.6 bottles. Here we've paid for 4 bottles. And it would actually be the same thing here, right? Because you buy one, get one free, buy one, get one free, buy one, get one free. So the cheapest way in this case is just to buy all of them from shop B. Okay? And the reason why this is interesting is because you need to be able to use you can kind of give them your own value, like you can say they're £2 each or something, and try and work out the cheapest price. But hopefully this also makes a bit of sense. It tells me here that 0.8 recurring is equal to 8 over 9, and we need to use that fact to show that 0.08 recurring is equal to 8 over 90. Well, again, it's meant to be fairly easy. All you need to do is that if 0.08 recurring is just equal to 0.8 recurring divided by 10. So that would be 8 over 9 divided by 10. How do you divide by 10? Keep, flip, change. You have 8 over 9, keep that the same, flip the next bit and change it to times, which gives me 8 over 90. And it says using part A or otherwise. Remember, when it says using part A, you should probably use part A. Convert 0.28 recurring to a fraction. Well, 0.28, if I need to use this first part here, it means I need to get 0.08 by itself. So that is 0.2 plus 0.08 recurring. 0.2 as a fraction is 2 over 10. Plus, and 0.08 is 8 over 90. Now, yes, you could have done that as 1/5 if you wanted to. So to make them the same, we're going to times this one by 9, top and bottom. We're left with 18 over 90 plus 8 over 90, which is equal to 26 over 90. Simplest form, so we can half it, we get 13 over 45, which is indeed the simplest form for that fraction. Cool. Oh look, circle theorems, everyone's favourite. So we have DEF are points on a circle. EF bisects the angle DFQ. So what that means is this is also X, because they bisect each other. And PFQ is a tangent to the circle. Now again, do you remember what the kind of rule is here? Because we have kind of a chord going along here, right? We're going to have the alternate segment theorem, okay? So I've done that circle theorems video. If you haven't seen it, you should probably check it out if you're not too sure. It says prove that DE is equal to FE. So in other words, we're trying to prove that this is a big ol' isosceles triangle. Okay? Now if you remember, an isosceles triangle has the same base angles. Okay? Now because it says prove, I need to actually start by doing this. So DFE equals EFQ because it's 2 halves of a bisected angle. Remember, to bisect means to cut in half. Okay? That's the first step. Now I'm going to use the alternate segment theorem to say that this angle here at D is also equal to this. So FDE equals EFQ alternate segment theorem. And again, if you're a bit unsure of those circle theorems, you should go and watch the circle theorem video, because we literally go through all of them in order really carefully, do a bunch of practice questions on them. So if I look at this, I have these two angles are the same, which means base angles are the same. So this is an isosceles triangle, which means FE must equal DE. So I'm going to write that out. FE equals DE because FDE is isosceles with base angles FDE and EFD. So it's a fairly unique proof in the sense that you have to kind of prove this thing. And yeah, so I kind of came up with it in a somewhat interesting way. again, I do think they're going to do this kind of proof where it's like algebraic, okay? I don't know if it's going to be this exact proof. I have a hunch it might be, but hopefully that makes sense. Irregular pentagon, okay. Find the value of x, okay. So the word irregular means that the sides and the angles are not all the same, which is important because if it was, then everything here would be 85. We need to find the value of x. So what we need to do is, because they've only given me angles, I need to work out what all of these angles should add up to. And this equation is what you use. Now, this equation isn't used very frequently, but much to my surprise, a lot of students don't know about it, right? This is a really important equation. What it does is it gives you the total angles in an n-sided shape. So in this case, it's a pentagon, so we have 5 sides, so n would be 5, right? So for example, with a quadrilateral, that would be 4. 4 minus 2 is 2, times 180 is 360, right? Triangle, that has 3 sides. 3 minus 2 is 1. 1 times 180 is 180. So it does work. It's a really important one, and it is on your spec, okay? So in total, it should add up to 5 minus 2 times 180, which is 3 times 180. Again, you can use whatever method you so wish, but you should get 540 degrees, okay? And we know that all of this stuff here added together should give me 540 degrees. So let's do it. I'm going to start with this one. And what I like to do, because people tend to, including myself, tend to forget which ones they've done, I'm going to tick it off as I do it. It'd be kind of embarrassing if I get my own paper wrong. Plus 85 plus 2x minus 15 plus 4x plus 8 equals, and I'm going to take it off, 540. So now I'm going to gather all of my x's together. That's 1x, 2x, 4x, 8x. So we're going to have 8x. Now adding these numbers up, we can do 42 plus 8 is 50, obviously. Minus 15 is 35. Add 85. Let's quickly do that. 85 plus 35. That's 10. So that would be 120. So plus 120 equals 540. That should be correct, I hope. So 8x is equal to 420. So I hope that makes a bit of sense so far. And now we need to divide these two things. So sometimes, by the way, if it's an even number like this, I might just keep halving it. So 4x equals 210 until I get to one that's kind of like easy to do. So 2x is equal to 105. So then x is equal to 105 over 2, which, if you're not too sure, is just going to equal 52.5 degrees. Cool. So I can keep halving it, right? There's no harm in doing it. So I'm trying to use these questions as like a way to demonstrate to you some alternate ways of doing mental maths, which might be a little bit easier and less taxing on the brain. Okay, diagram shows 2 right angled triangles, and we need to work out the value of x. Okay, so if we look at the information they've given us, how can we work this out? Well, if I'm looking at x here, I can see that I have the angle and I have nothing else. So I can't work out x yet. But I have an angle and a side here, and this side is joint between them. So I'm going to try and work out that side, which means I'll have an angle and a side, which means I can work out what x is. So let's get to it. 5-mark question. Not too bad, but it's a non-calculated paper. We need to do trig. So if I label up this triangle, we have the hypotenuse, we have the opposite side, and therefore this must be the adjacent. So in this case, if we use SOHCAHTOA, we have opposite and adjacent, so we're looking at TOA. So tan 60 is equal to y over 6. So y is equal to 6 tan 60. Okay? I hope that makes some amount of sense. Now, hopefully you remember that tan 60 is one of the values of trig that you need to know. And it is indeed root 3. Okay, so now looking at x here, again label up the sides, we have the hypotenuse, we have the opposite, so that's still O, and this is the adjacent. So we're using TOA again, however we have tan 30 equals the opposite side, which was 6 root 3, divided by x. So if I rearrange this quickly, we get x tan 30 equals 6 root 3. So what is tan 30? Well, again, tan 30 is also one of the values that you need to just remember, and it is root 3 over 3. So we have x times root 3 over 3 equals 6 root 3. Now, because root 3 is in both terms, I can actually cancel it out. Times both sides by 3, and I get x is equal to 18, which is the final answer there. It's 18 centimeters long. Hopefully that's okay. And that brings us to the end of the paper. Not too bad, I hope. Again, so someone did ask me, like, is this a grade 9 paper? It's not a grade 9 paper. This is what I think the actual paper would be like. So if you have been practicing the grade 9 papers, it's going to be a lot easier than the grade 9 papers, which is a really good sign, right? Because again, grade 9 is supposed to be the hardest it could possibly ever be, ever, right? So hopefully that makes sense. Again, all of these papers and the future mark schemes will be put in the Discord, so I'd recommend that you join that. There's a bunch of people like asking for help and things like that. I answer a bunch of questions too. So if you go into the kind of maths help channel, there's a bunch of pictures of me just sending off a ton of answers to various questions. So it's super, super useful. But anyways, I'll see you in the next one, and I hope you have a wonderful day.